stay here. Besides.
You were holding the elevator door?
Yeah.
You were holding the.
Okay, we're gonna wait until 7:05 and then we're going to start the lab session. So please remind your friend if your friends haven't joined the lab session yet. And please open your cam because we're gonna check the attendance from the camera every submodule. So if your camera is off, that means you're not attending the lab session. Yeah, this meeting will be recorded. Okay, you may go to the bathroom first. Okay, because it's already 7:05, we're gonna start the lab session. And okay, I guess so we're not gonna call you for your attendance check, but we're gonna check your camera to to check the attendance. Okay, so if you guys still off cam, and then you're gonna be marked as not attendance. Okay. So the first module of computer network lab session is about crimping and Wireshark, and the first one will gonna be explained by by my friends. Rafif, are you there?
Okay.
Okay. You can share your screen.
Okay, let me share my screen. Okay. The first thing you guys to know for the network is the basic command lines. First one is telnet. So let's say you want to access your other computer or your other server, and you want to access it. Oh, sorry, wait. Okay, sorry. The first one, the first basic command line is telnet. So let's say, for example, you have a server that located in New York. So you want to access your server. You don't have to go to New York and open your server and access it in New York, but you just have to access your server in Indonesia. Like you just use telnet to access your server. Just like this. This is the command line telnet, google.com, and port 80. 80 is, for example, is the default port for web server. So just like this. So maybe I can wait. So let's say telnet google.com and the port is 80 and it is connected to google.com. Okay, so you can access your server remotely and you can configure your server. This is the other example, just like this. But the weakness of telnet is it is not secure because the data that you send to server is not is encrypted. So maybe anyone who wants to access can see the username and the password. So a lot of people migrating to SSH secure cell. It's just like telnet, but the data that you send to server is encrypted. So no one can see your data that you send. For example, just like this, just like this, SSH username, and the host. Like maybe if you want to remote through internet, so the host must be public IP. But if you want to remote using like local area network or LAN, you just put your private IP, just like this, just like this. Okay, and the third one is Netcat. Netcat is like if you want to test your application, like your server, you just put Netcat. The command line is NC. NC stands for Netcat, and the options in this example, the options is example.com, and the host and the port is 1234, just like this, only for example. Okay, and the last one, the basic comment for the last one is ping. Usually I use ping for I want to check if my computer is connected to internet or not. So you can use terminal. Wait. Okay, just ping google.com. So it means that you send your data to google.com and the Google send me a response. 64 bytes is the size and 142.251.12.138. It is the IP of the google.com, and this is the count. Yeah, time is for the time, the response time, just like that. So the lower you get, the better response that you get. Yeah, just like that. It's just like this. Or if you want to, maybe you want to only receive a response for only 5, you can do min-c5 google.com. So it will automatically exit after 5 response, yeah, just like that. Okay, that's all for basic command line. My friend want to continue the module.
Okay, so now I'm going to explain the submodule 2, which is, oh, I'm sorry.
Sorry, Arif, I guess it's my turn and Kaysa.
Yeah, I'm sorry.
Okay. Okay. Can you turn off your screen? Can you stop share your screen, Arif? Okay, thank you. So I'll continue this one with IP and port concepts, and the port concepts will be explained by Keisa. So we're gonna talk about the IP concept itself. Do you ever wonder how the internet works when you type Google and whatever it is on the address? Actually, the internet doesn't understand the name Google itself. They understand how an IP address is work. So to determine where to send data, we need IP address to go to certain domain name like google.com. For example, google.com actually linked to an IP address of 8.8.8.8. So what is IP itself? IP stands for Internet Protocol, and just imagine like you have a neighbor and maybe some neighbors, and you cannot distinguish them one another if you don't know their houses. Right, one of them have their own house, like maybe a pineapple, just like SpongeBob, or even a rock like Patrick. Each device, such as a computer or smartphone, has their own address in the network. When you send something like a letter or data, you need the recipient's address. That's the IP we are talking about here. So that your delivery reaches, so we need that kind of thing. So your delivery reaches the correct place. Similarly, an IP address ensures that data sent over the internet reaches the right devices too. As I mentioned before, IP stands for Internet Protocol, and the Internet Protocol is going to be something to identify any devices that connected to a network. Okay, so there are 2 types of IP addresses, the IP version 4 and IP version 6. The most commonly used is the IP version 4 with a length of 32 bits and 4 section octets, like this one, the first octets, second, third, and the fourth. It's separated by dots. Don't be fooled by this one. It's semicolon. So each octets in IP version 4 ranges from 0 to 255. With this setup, with this kind of combination, it can be estimated that there are about 4.3 billion different IP version 4 addresses worldwide. And when this one is made up, everyone thinks it's enough. But we're gonna talk about it later. So the example of IP version 4, including this one, like 169.89. Blah 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 and blah blah blah. So because it is the most widely used, almost all systems can handle IP version 4 routing without issues because it's one of the most commonly used IP address. And IP version 4 support most network topologies because they're simple prefixes. Like you can just see this and it's not that complicated, right? Data in IP4 version 4 is also well encrypted, just to make sure that the communication is secure between networks. We have talked about the 4.3 billion IP4 before, and back when they made this one, people think that 4.3 billion is enough, but they're wrong, and IP version 4 is come to its end. So they're making this IP version 6 with a new, which is a newer version of the IP address, designed to replace IPv4 because it's limited numbers. IP version 4 has 32 bits, which is not enough, and IP version 6 has a length of 128 bits. This means that there are 340 undecillion. Yes, you can count it like about 66 zeros different IP version 6 addresses. And it's written in 16-bit hexadecimal digits and letters. So if you're familiar with digital system before, there are 0 to 9 and then A to F in 16-bit of hexadecimal. It's separated by colons, and therefore you will encounter letters from A to F, as I mentioned before. This is the example. You might see this like this and that and that, and I guess we missed some answer here. With IP version 6, routing becomes more efficient because it allows internet service providers to minimize the size of routing tables. IP version 6 also uses Internet Protocol Security or IPsec, so you don't have to worry about the authentication. Okay, about the data confidentiality and integrity, I guess it's also secure. IP version 6 does not have IP checksum, so the packet transfer is more efficient and support multicast as multicast. As a result of that, multicast data can be sent to multiple destinations simultaneously, saving network bandwidth. Okay, so I've explained about the internet protocol itself, and we're gonna explain about the port allocation. Keisa, are you there? You want to share your screen, your own screen?
Yes, I want to share my own screen.
Okay.
Okay, let me check. Okay, so the next one is about port allocation. You already know about the IP address. So the IP address is like the address of a building, and the port is like a room number in that building. So, and in example, you visit a building, you give the receptionist the apartment number you want to go, so they can direct you to the right place. So if you order some food, you need to give the IP address or like the address of the apartment, but you need to give the room number of your room, right? So the room number is like the port number, and the address of the apartment is like the IP address. It's the same like in network. So every service or every app that run in our computer is having a port dedicated to that service. So if we want to send a data between computer, so we need to specify the IP address and specify the port number of the service we want to make a communication. Okay, so this is the logical port. They have a standardized system across all network device. So every device is having a same standard between other. It's identified by 16-bit 2-byte number called a port number. It's range from 0 to 65,000. Okay, so and the dividing is first 0 to 1,000 is well-known ports that usually we can use this for our needs. So it's usually for the basic commonly used logical ports. And then the registered ports is between 1024 until 49,000. And the dynamically assigned port is from 49,000 until the end is 65,000. And this is some examples of commonly used logical ports and their functions. For example, is 20 and 21 is used for FTP. And for the SSH that already explained by Rafif is using the port number 22. And the telnet explained by Rafif too is using the port 23. And like the web browser that we usually access, like HTTP and HTTPS is usually for HTTP is using port 80, and for HTTPS is using port 4043. Okay. So usually you can check your port using the terminal. Wait, I'll demonstrate it. Okay. So you can check your, if you are using Windows, actually, you can do run as administrator, and you can do netstat main anop. And this will be the list of your port that already used, or you can see like all service that I have, like right now it's running like Postgre, like this is Postgre, and Zoom, Opera, all my service is having the dedicated port for that service. So every app having the different port between another app. So it's more easy to manage. Okay, I think that's all for port. Maybe we can next to wireframe.
Okay, before we are going to the wireframing, is there anyone who wants to ask for the port allocation and the IP before we go to the next section? Please keep your camera turned on because it's just the rules that you have to obey. Okay, 5, 4, 3, 2, 1. Okay, it's clear enough. We can go to the next section.
Okay, so now I'm going to explain the second submodule, what is wire crimping. So, what is wire crimping actually? Wire crimping is a process when you build a unshielded twisted cable into an Ethernet cable, a usable Internet cable. So it's a process wire crimping, which is going to be tested tomorrow by us. You are going to build the wire and we're going to test it if it's right or not. So let me give you an overview. What is the component we use for wire crimping? Uh, the first, of course, the UTP cable. What is UTP cable? So UTP cable is a short of unshielded twisted pair. That is that's a cable, and usually you find it behind your Wi-Fi or maybe your LAN cable. It's almost everywhere right now. But why do I, why do we actually need UTP cable for our communication if there is a wireless module over here? So imagine if we are going to communicate into another country. Back then, there is no such tools like satellite to transmit the signal as far as country A to country B. So they need to build a cable under the sea to connect each country and each city and to connect all the world. Of course, we not using the UTP cable because it's unshielded. And why we are using UTP cable right now? Because it's easy and it's cheap to obtain. Um, the better option is actually the shielded twisted pair. I'm going to explain it later. And inside the UTP cable, you can see over here, there is like four twisted parts with this orange with white and this green with white, brown and white, and then blue with blue. So what does that actually mean? Yeah. Wait, let me give you an overview. Where is it? Where is it? It's going to be look like this. And this white isn't just actually white. It actually has a stripe in it. Like if you see this blue over here, it's white and blue, not just white like that. And each color of the cable has its own purpose. So the purpose of the orange and white orange and green white is to transmit the data, to receive and sending the data, and the brown and white brown is to flow the AC current, the one way current, not the DC one. And then the blue one, I kind of forget. Maybe it's unused for the data transmission, but it's responsible too for the AC current. Okay, and then you're going to need a RJ45 connector. So RJ means it's I kind of forgot what RJ stands for, but this is the standard connector that we use everywhere for Ethernet cable. You can see it, the port inside your laptop, me or maybe your computer. They must be have at least one RJ45 port. So this will this will connect the cable into the end device. So the final look is, yeah, you guys should be known. The final look should not far from this. This is the shielded one. I'm sorry. So this is the cable and this is the connector. So yeah, the crimping is actually just connecting the wires to the SG45 connector. So as simple as that. And then we got the crimping pliers. These pliers actually has a lot of use. So we don't need scissors to open the cable jacket maybe. We can use these pliers to cut the cable, to open the jacket, what it mean, to press the plastic inside the connector into the wire. We just only need this one tool to make a Ethernet cable. And then to test if our crimping is successful or not, we can use the LAN tester to test. I cannot demonstrate it right now because we don't have I don't have the tools inside my room right now. Okay. And then the cable configuration. So in the Ethernet cable, there are two types of cable configuration. First one is T568A and the next one is P, just A and P difference. What is the difference? So the difference is the placement of the color. So if you look at the A section, there is white green and then green, white orange, blue, white blue, and then you can you can compare these two. Yeah, you can see this. What does this actually mean? So we use this two type of cable configuration to build a straight through cable or a crossover cable. What is the purpose of straight through cable and crossover cable? Yeah, as it explained in text, actually straight through cable is used to uh, connect a DTE device to DCE device. That means different device. Example, like you want to connect your laptop into a router or a switches or modem. Yeah, you need a straight through cable for that. But right now, actually, uh, computers are already smart. Yeah, and we can use any type of straight through cable or crossover cable to connect any device in the any hardware that you have. We can only use one. We can just use straight through. Actually, like that. I forget what the process is, but yeah, that's possible. And then the configuration at straight through cable is in the end of the cable. It must be the same cable configuration. For example, if the one point is ended with this type of configuration, and then the other point must be the same. So yeah, it's paired. It's paired. Like if you use, yeah, you know what I mean. Lah. There's two type of configuration possible, right, for the end. And then uh, the crossover cable. So the crossover cable is actually to connect the same device. Example for DTE device or to DTE device or DCE to DCE device. For example, yeah, we have our laptop to connect to our laptop. So we need to use a crossover cable, routers to routers, and then routers to switches, and many more. And the installation is uh, different from straight to cable. If the straight to cable one and the other end must be same cable configuration, the crossover cable has the different type of and each end. So if the one you built is already built in T568A configuration, the other one must be built in T568B and vice versa. Just there's only one possibility for crossover cable. Okay, that's the configuration, and this is actually the crimping steps. We will also do a demo for tomorrow offline test. So yeah, as we can see, we need the tools, and then we need to strip the UTP cable shield. The cable shield is the jacket. Yeah, the if this you can see this gray color, that's the jacket. We only need this white this twisted cables. And then we need to sort the cable into the configuration need, either straight, cross, or yeah, or other. And then we need to cut the end of the wire, insert the flattened wire into the SG45 connectors, and then we need to use the pliers to lock the UTP cable and the RG45 connector, and then we need to use the LAN tester to make sure the cable is working properly. Yeah, there's a lot of tutorials in YouTube. You can watch it if you're curious right now. We're not going to play in here right now because yeah, it's going to waste up the time. Uh, before moving to the next section, is there any question? One, two, three, four, five. Okay, I think there's no question. Maybe we can next may to the next step workshop. Wait, I cannot stop the share. Never
Wait a minute, guys. I will restart my Zoom because I will need to allow the preference settings.
Okay, there is a question in the chat. For tomorrow, it's cable cramping only, right? Is it all of the cable configuration? Then no. So for tomorrow, we're only gonna cover for the straight configuration using the B version. The wait, I forgot. Should be the T568B type, if I'm correct. So you need to learn just that straight configuration and T6 568B for tomorrow. Okay, I guess I'm already here.
Can you see my screen, guys? Yeah. So the next one is Wireshark. Wireshark is a network packet analyzer application in which we'll use as a tool to capture packets. So as we know, data are sent over the network in form of packets, and we will use Wireshark to capture those packets, and Wireshark can also display the details of the package. So for the package itself, packets have a structure. It contains of header, payload, also referred to as body, and a trailer, which are sometimes also referred to as a footer. Which is basically header contains the information or the metadata of the packets, and it contains a few information such as packet length, which will show the length of the packets, usually in the form of bytes. Then there is synchronization, which is a bits that is used to identify whether the packets are synchronized with the network and the receiver. Next one is packet number, which is the order of the total packets available. So usually packets come in a certain series of packets, and packet number can be used to identify the order of those packets. The next one is protocol. This will gives us the information about the protocol, the type of the protocol that is being sent. For example, SMTP for email or HTTP for web pages. Then there is the destination address, which is where is the packet sent, and the source address, where did the packet come from. The next structure is the payload. Payload is the body of the packets, and it contains the main data that is being sent in the packet. The last one is trailer. Trailer contains bits which will signal that the packets have already reached the end. So to summarize, the header contains the information, payload is the main data of the packets, and trailer will identify whether the packets have already reached the end. The next one is installation. Maybe some of you guys have already installed the app during the class, but for those of you who haven't installed it, you can click on this download link. And for Linux user, maybe some of you are Linux user, you can see the tutorial here. After the installation is complete and you open the Wireshark, there you will see this main window, which we will see a list of network that is connected or available on your device. To start capturing, you can click on the blue fin button on the corner, and to stop capturing, you can click on the red square corner button. To connect to Wi-Fi, usually it's either WLP like in this photo, or Wi-Fi, or sometimes it's WLAN, depending on the operating system you're using. So the next one is filters. So when you start capturing at Wireshark, it will automatically capture many packets that are going in and out in your network. So we will want to have a filter to search for the packets that we are going to specifically search. There are two types of filter to do that. The first one is capture filter, and the second one is display filter. So the main difference is when you do capture filter, you will capture you will do the filtering before you capture the packets, and for display filter, you will do the filtering after you capture the packets. You can do capture filter by putting in the syntax in this green bar. If you see in the main window, in this green bar is the capture filter bar, and the blue one is the display filter bar. Okay, so when you do a capture filter, packets that doesn't meet the criteria are allowed to pass without being captured. So you'll only, if you type in HTTP, you'll only capture HTTP packets, for example. And the syntax of capture filter can consist of one or more primitives. Primitives is in the syntax of capture filter is basically a qualifier and an ID. This, for example, like this is one primitive, and in a capture filter, it can contain more than one primitive, which we will combine and connect them using the operators such as and or maybe you can use negations. For the qualifier itself, there are three types. The first one is type qualifier. This will specify the type of the or the ID. For example, host, usually for IP, net for network, port, and or port range. The second one is direction. This will specify the direction of the connection. For example, source. This means that it's from a specific connection, or this DST or destination is to a specific connection. And the last one is proto or protocol. This will specify the protocol. For example, TCP, UDP. These are some few examples of the capture filter syntax. The first one, host 10.151, this IP address is basically the syntax will capture the packets from and to the address of this IP. So if you don't specify this like source or destination, it will capture from and to the address. Well, if you specify the source using the source qualifier, source IP address, it will only capture packets from the address of the IP. You can also use net or network. This is to capture packets from a specific network. For example, in here, these are from a subnet of this subnet, or these two are basically the same. You can use either the net mask like this, or you can use /24. And you can also use destination in the network syntax. Basically, you can just try to combine all of the qualifier and experience itself. And the last one, this is an example of two primitive syntax, which are combined using an operator or. For or, you can either use or in English or you can use a double line like this. And it will capture all packets with the TCP protocol from the source of port 22 or packets from the IP address of from or to the IP address of this. This is the example of the first example. As you can see, this will result in the packets contained from the source or to the destination of the IP address. If you check, all of the packets here are either from this IP or to this IP. So that is when you do a capture filter. The next one is display filter. Display filter is you're filtering the packets after it is displayed from the capturing process. And the syntax is protocol, field, comparison operator, and value. For comparison operator, you can see from this table the comparison operator that you can use. You can either use the English English syntax or the C-like syntax for equal, not equal, greater, less than, etc. And for contains, this will search for the packets that its protocol or field contains a value, while match will search for filter packets which its protocol and or text field match a regular expression. So basically it's quite similar, but usually we use contains for a string and we use matches for more like a regular expression, a complex regular expression. You can also combine display filter with the logical operator, such as this operator that you can use. These are some example of the display filter. TCP port equals to 443. Then this will display all the packets with the TCP protocols from the port 443. And the second one, IP source equals to IP address, or IP destination equals to IP address. It will display all the packets from the source of this and or the destination of this IP address. And the last one is a contains syntax. In here, it will display that a packets that is in the protocol of HTTP and in the field of request URI, it should contain the word login. I think there's a typo here. It should be contain. You don't need to put S in here. And the thing you should remember if you use the contain syntax, you should put double quote between the string that you insert as a value. This is an example of display filter. As you can see here, the result after putting in tcp.port equals to 80 will result in displaying all the packets that is to or from the port 80. You can also export capture data after you capture it. You can do that by simply clicking on the file and choose export object. There will be a few options of export object that you can choose. For example, HTTP, and then you can choose, and it will display all the HTTP object that is available to export. You can choose one of them and click save to save the export object, and it will be exported successfully. And okay, and by the way, you can also import a file to Wireshark, basically, usually it's in the form of pcap file. Before we continue, is there any question other than? Yeah, Muhammad Yusuf Haidar.
Yeah, Mas, excuse me. For the display capture, can you go up?
Yeah.
I think the first one, the you mentioned about the display, right? The display, that one, below.
This one.
Yeah, that one.
Yeah.
Why is there the from the source the filter is host 10 151 366 and 1, right? But is 114 counted as the same, so it's like anything that start with apa namanya, the last one is 1, and there is also some others, right?
Oh, okay.
Mm.
So this, do you mean this one? This one?
Yeah, I was actually specifically asking about the 114, right? From the source and also destination.
Oh, so this syntax will capture the packets from either the source or destination of this. So if you see,
Oh,
even if it's 11114, the destination of the the
yeah.
destination is still this IP address. And the same for this packets, for example, the source are still this IP address. So if you don't specify the source or the destination of the IP, it will filter either source or destination of the IP value you input, like that.
Okay, yeah. I forgot the from/to. Yeah.
Yeah.
Yeah. Okay.
Okay.
Okay. Thank you, Mr. Mas Ara.
Okay. Is there any question? Okay, maybe we can go on to the next one.
Okay, we're going to go to the next material. So the next submodule or the next topic that we're going to cover is how to use Wireshark with FTP server. So as you can see before, we are using Wireshark to capture packets that transfer through the internet, and it's most of them are TCP protocol. So maybe you're wondering or asking how to capture from FTP. So if you doesn't know, FTP server is a server that can transfer file, or FTP actually stands for file transfer protocol. So you can quickly share a file from a network. And basically, most of the website actually use FTP as well. So sometimes if you're capturing package from your Wi-Fi and then you're accessing a website that you're using FTP, sometimes you count FTP protocol in the packet. So in here, how to try to capture FTP server is we're going to use the FileZilla. FileZilla is one of the server and client that utilize FTP protocol. So in here, we're going to use two applications. So for the first application is the FileZilla server, or you can actually use XAMPP if you have them. And then start the FileZilla server in here. Okay, it should be started. And then we're gonna open up our Wireshark. And because we're testing on our local machine, so we're not gonna send or receive from another computer, we're gonna use the adapter for loopback traffic capture. This is like the adapter for our local computer. So if you're testing and then the server and the client is on the same computer, just capture this. So I'm gonna start capturing this, and you're gonna apply display filter and then just contain FTP. So we already started, and then you're gonna open the admin panel in here in the FileZilla. In here, what we need to do according to the module is to create a user. So in here, I'm going to create a user using edit and then users. And then in here, you can add a new user. Let's say user test 2. And then we're going to go to the shared folders and then just add your folders. So let's say I'm going to add temporary folders. This folder is going to be shared when you're logged in the FTP client or FileZilla client using the user test 2. So let's say we allow all of the permissions to create, read, and write. And then we click OK. Okay, so we're already done with the FileZilla server setup. Okay, and the FTP server is already running in here in localhost port 21. The next step we need to do is downloading the FileZilla client. So you can go to FileZilla client in here. I guess you need to go to the download one in here. Download FileZilla client and show additional download options. So there are a bunch of operating system that you can choose. If you're using Windows, just click the setup Windows, and if you're using Mac OS, just choose like the specific according to your operating system. Okay, and then after that, you can open the FileZilla client, and we're going to connect to our server. Our server is in localhost, which mean, or you can see in here, I guess. Let's open the admin again. See, this one is the server address 127.0.0.1. It means localhost IP. And then for the username, we're gonna try using user test 2. And then for the password, because we haven't set the password, so we just leave it empty. And then for the port, you can use one of these, 21 or 14147. So in this case, I'm gonna use 21. And then just do click connect, and you're gonna be asked for the password again because we don't specify any password, just enter blank. And then this server does not support FTP over TLS. So what FTP over TLS mean is a secure FTP. So the same as HTTP. HTTP has HTTPS as well. So HTTPS means that it's actually HTTP protocol, but running over TLS. So what does that mean is that if you're running HTTPS, you can't sniff using the Wireshark. But if same as HTTP, FTP also does that. So if you're running a server on FTP, you can sniff the package through Wireshark. But if you're running FTP over TLS, you can't sniff the package. So in this case, this is just a warning that our connection is not secure. So we're just gonna okay right here. And then if we go back to Wireshark, it should be put in here. So as you can see, there is auth, which is like the login to the FTP. And you can just actually follow the TCP stream. And then you can like user test 2, and then the pass, there is no password. So in this case, you can just sniff like the FTP connection. So let's just try to make another user that has a password, and then we can see if it's visible in the Wireshark or not. So let's say we're gonna add user test 3, and then we check the password and then enable password. Let's say user test 3, or we could say password, or maybe pass 1, 2, 3. And then for shared folders, I'm gonna add like the same as before. Okay. Okay, it's already done setting the account. And we're gonna log in using the user test 3. And we're gonna ask the password. So let's say pass 1, 2, 3. Let's just abort previous connection. Okay, if we go back to Wireshark and we are searching for the user test 3. Is there any? Okay, because this is still applying the current filter, or just FTP contains user. Okay, in here, we're gonna follow the TCP stream, and as you can see in here, the password is visible to the Wireshark. So that is actually like not a good way to use connection not over TLS. So if you're visiting an HTTP website and then you're like providing your credential, username and password, and then someone in the same router or in the same network as you sniffing your transaction using Wireshark, they might get your credential, username, password. Okay, we're gonna go to the next. Okay, in here, we're not going to use the Linux command because we're using the FileZilla client. It's easier. And then this is just the Wireshark, the capture of the authentication, as I showed before, that this is the authentication for. So first, the client is requesting for TLS, but the server is not providing the TLS. So TLS and SSL is not allowed, and then go to the login section, which means you need to provide the credential of this. Wait, why is this user test 2? Should be user test 3. Let's say user test 3. Let's follow this TCP stream. Okay, and then it just a comment in FTP. So if you're using or if you want to craft your requests yourself using FTP, you can use this command. User mean username used to log into the server, and then PWD is password that used, or in this case it's pass. It's the same. Wait, it should be pass. Okay, so the command should be pass, stand for password, because PWD is requesting for friend working directory. In here, you can see that the command is PWD, which is requesting for the current working directory, which is the server gonna return to the slash. It's the current working directory. And then another command in FTP is store. Store is uploading files to FTP server, so we can try by opening up our FileZilla client or FTP client, and then to upload to the file server, you can just drag and drop this. So let's say I'm gonna wait. I'm gonna upload this. So I'm just gonna drag this and then put this into here. So okay, it says critical file transfer error because the connection is timeout, so we need to connect again. Wait. Let's just use user test 2 because it doesn't need. Oh, yeah. Let's just type in here. That's 1, 2, 3. Okay. The connection is successful, and then when why it's permission denied? Wait. We need to open the FileZilla admin page again. And then let's see if we're okay, because it doesn't has the access, so we need to enable the access for write, delete, append, create, and delete to the user testee. That's why we can upload our files to the server. So let's try that again. We just restart all of those. So let's just recapture our Wireshark. To restart capturing, just click the green one. So it's gonna restart the connection, and we're gonna restart the connection and upload this file into here. See, it's gonna appear in here. And when we filter, FTP contains user test 3, and then we're gonna follow the TCP stream, and you're gonna see a comment to upload a file to the server. In this case, is store A4 blah blah blah. Here we go back to the module. See, this one is STOR to upload to the server. And then to download from the server, it's gonna say, or the comment is RETR. So we're just gonna move this back into here and then just type overwrite whatever. And then let's see. Okay, let's just close this first. And in here, okay, I just filter that again. Follow this. It says RETR, which means we download files from the server to the client. See this one. So if you're using Linux command to operate the FileZilla client, you can use get, you can use put, you can use FTP to connect, but we have the GUI for FileZilla client, so you don't need to type all of those things, just drag and drop. And if you delete in here, let's try to delete. Yes, and then it should be another comment. Okay, let's see in here. TCP or FTP contains resource. And then this one. So it should be delete, DELE, to delete the file. Okay, you can try it yourself, but typically in the lab work for the Wireshark, you don't need to do this. You don't need to actually sniff the data or the packet. You are going to be given a PCAP file that we already prepared. So I'm going to just show you like this. So you need to download the PCAP and then open it, and then it's gonna list all of the packet. And then from this information, you're gonna be asked some of questions, and then you need to answer to this question. So typical question is how many HTTP connection in this capture? Let's say HTTP, and there is none. And then for FTP, there's a bunch of FTP because this is the only sniff the FTP protocol. So maybe you're going to be asked for the password. So if you're asked for some user that log in to the FTP, you can use the filter that I used before. FTP contains, let's say, user, to see all of the user. There are user this, user FTP, user. Okay, so only 2 users that used to log into this FTP server, and then to see the password, just click follow stream like this, and you get the password. The password is FTP. And then maybe another question is you're going to be asked like what this user do, something like that. So maybe FTP contain FTP. Oh, what's okay. So to see what are they doing, you can just open in here. Okay, I guess you need to follow the TCP. So for example, this is a login incorrect because it's incorrect password. So you need to find which one is the correct login. Okay, I guess. This one, user FTP logged in, is the correct logged in. So you can just follow this. Okay, so you got the password, and then what are they doing? They just quit after logged in. So they're doing nothing. The typical questions that gonna be asked are probably gonna be like that. And for the module, I guess that's all. This is for the exercise. What is the difference between capture filter and display filter in Wireshark? So, okay, based on capture packets. So capture filter is gonna filter out the packets that you're gonna be capturing, but display filter is to filter like the packets that you need to display. So, so for example, in here, you want to just wait, you want to just apply or just capture the FTP. You can do this. And I need to close all of the Wireshark. You can do something like TCP port FTP, something like that, to capture only FTP. And in here, you won't see like all of the noises for TCP before, because for other usage, you only see like FTP connection or transaction. Okay, the next, what is the difference between IP.dst filter and IP.dst host filter? Okay, I guess for the rest, you can try to answer them yourself. like do a ping on 1111 Cloudflare server, apply a display filter that shows the package in questions, then find out what protocol is used. Okay, you can try that. And then go to blah blah blah, and then get the source file index.html using Wireshark. You already got this in the class before. We demonstrate how to get the content or the source file using Wireshark before. I guess that's all for the lab session. Do you have any questions regarding this lab session? If you have any questions, just let us know. Or just, if you're shy, just type in the chat box.
Excuse me, Mas. I'd like
Okay.
to ask how, for the module itself, for the lab work that we're going to do, how much of it is going to deviate from the given module? Like, like,
Yeah, sorry.
can you hear me?
Yeah, I can hear
Okay,
you.
so I would like to know how much, uh, how much of the module, the lab work itself is gonna deviate from the lab work and from the module. Uh,
Okay.
will
Uh-uh.
will I'm not asking for the solution. I'm just asking, will most of the solution, will most of the problem, will the problems in the lab work gonna be solvable with just from the module's knowledge, or do we need to, or
Mm.
is
Yeah,
it
I get your point.
okay?
So for the lab work, for this gonna be two lab works, right? They're gonna be two lab work. For the first one is is crimping, which is tomorrow. I already tell you guys what you need to do for tomorrow. So for the Wireshark lab work, mostly, I guess all of them, only using the which one? The display filter. So you need to know how to use this display filter, and then use this combination or this filter expression to find out what what you need to find out. So we're just gonna ask a questions like I showed you before. What is the password of this user? And then what you need to do is just applying a bunch of display filter. I guess in here, okay, I guess there's not much information in this module. So basically, what you need to study or what you need to learn is about display filter.
Okay.
Yeah.
Thank you for the response.
Okay. So most of them are about display filter. Something like this. Something like this. Do you have any other question? Because it's still 8:20. If you have a lot of question, it's fine. It should be end in 9 p.m. But it's still 8:20, so you guys can ask a question. Or I guess I'll wait until 8:21 if you guys don't have any question. We just end the meeting. Is that okay? Okay, it's 8:21. Okay, I guess for the assistants, do you guys have something to add, or is that enough? Assistant, Fred, Kesa, Raihan, Rafif,
Yeah, I'm good.
Arif, okay. Okay, I guess that's all for today lab session. If you guys still have a question after the lab session, you feel free to contact us via group or via like DM. And I will share the recording maybe tomorrow or maybe this night. Thank you. You can leave the meeting.
Thank you, Mas.
Thank you, Mas.
Okay. Thank you, Mas.
Thank you, Mas.
Okay. Ayo.
Ayo Rafli.
Halo Rafli.
Raffi ngapain? Ayo.
Ayo pasti nggak
Ayo, ayo.
didengerin.
AFK, AFK.
Wah, udah gelap.